Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to learn about the AASHTO soil classification system. This is the second part of the lecture 6, soil classification system. Now, in our previous lecture, we studied about the classification of soil. Older classification system such as the US Department of Agriculture, which is based upon the textural classification, was discussed, and the limitations of textural classification systems were also discussed. Now, in today's video lecture, we are going to study about the AASHTO soil classification system, which is one of the modern soil classification system. So we studied about the soil classification, why it's important, what we get from soil classification system. In our previous lecture, we also studied about the MIT system, US Department of Agriculture soil classification system, American Association of State Highway and Transportation Officials, and unified soil classification system. Then we discussed about the table where you can see the different grain sizes for gravel, sand, and silt and clay size materials. Two major categories were discussed. The older classification is based upon the textural classification, only the particle size distribution, and the modern classification is based upon the particle size distribution and the Atterberg limits. There are two systems, AASHTO and unified. AASHTO is our base topic. Then in our previous lecture, we discussed in detail about the US Department of Agriculture soil classification system. Then we discussed about the large size particle gives us the coarser appearance or coarse texture, and the smaller particles gives us the medium texture. The fine grained particles gives us the fine texture, and the pyramid was also discussed based upon the percentage of clay, percentage of silt, and percentage of sand, and the intersection point will give us the type of soil. Then we solved a few problems on it and the correction which will be necessary if the percentage of gravel is there in that particular soil. So we need to subtract that from 100% if you need to find out the sand, silt, and clay. And we also solved a problem on it, and we classified the soil. We discussed about the limitations, that only particle size distribution is discussed. However, plasticity, which is very important in changing the physical properties of the soil, such as the compressibility or the settlement behavior of the soil, is greatly dependent upon the plasticity of the soils. However, in our introductory lecture, we also touched about the modern classification system, and one of the systems is the AASHTO soil classification system. The basis for the AASHTO soil classification system is that the amount and type of clay minerals present in fine-grained soils dictate to a great extent their physical properties. For example, if we are having different types of clay minerals like kaolinite, elite, montmorillonite, different types of clay minerals will give different strength properties, different settlement properties, and even different permeability properties to the soil. Plasticity must be considered, which results from presence of clay minerals to interpret soil characteristics properly. So PI should be find out. Two other systems both take into consideration the particle size distribution and Atterberg limits. So these two systems are AASHTO and the unified soil classification system. Now, AASHTO stands for the American Association of State Highway and Transportation Officials. That system was developed in 1929. Originally, the system classified soil as being either group A material or group B material. Group A soil was able to maintain uniform pavement support at all locations, whereas the Group B soils were not. Now, the B designation was subsequently deleted, leaving only A soils in the classification systems. The A soils were subdivided into 7 soil groups, A1 through A7. So there are 7 soil groups. Soils are classified under groups based on particle passing percentage through the number 200 sieve. For example, if 35% or less pass through the number 200 sieve, those are A1, A2 and A3 group. If more than 35% pass through the number 200 sieve, those materials are A4, A5, A6 and A7 group. Simple terms, if you want to say that these are coarser particles, these are fine grained particles. Now, ASTM designation D3282 or AASHTO method M145 is used for the AASHTO soil classification system. Now, what are the tests required? There are different types of tests required. For example, to classify the soil based upon the AASHTO soil classification system. For example, grain size analysis is needed, liquid limit, plastic limit, those consistency limits are also needed to classify the fine grained soils. Now, what is gravel? Gravel is the fraction passing 75 millimeter sieve and retained on the number 10 or 2 millimeter sieve. Sand is a material or fraction passing through the number 10 or 2 millimeters US sieve and retained on the number 200 sieve. Size is 0.075 millimeter. Silt and clay fraction passing the number 200 sieve. Plasticity. Now, the term silty is applied when the fine fractions of the soil have a plasticity index of 10 or less. The term clay is applied when the fine fractions have plasticity index of 11 or more. Silt, silty, and if we are having clay soil, that will be having greater than 11 plasticity index. And we discussed about the plasticity index in our consistency states that this is liquid limit minus plastic limit. Now, if cobbles and boulders are present, sizes larger than 75 millimeter are encountered, they are excluded from the portion of the soil sample from which classification is made. However, the percentage of such material is recorded. Now, the AASHTO soil classification is present in a form of a table where you can see that the granular materials 35% or less of total sample passing number 200. These are A1, A3 and A2. A1, A3 and A2. A1 is subdivided in A1A and A1B. So this is the general classification. So the group classification would be A1A, A1B, A3 and A2 is having four subgroups: A24, A25, A26 and A27. Information about the percent passing, number 10 sieve, number 40 sieve and number 200 sieve is also given. In addition to the sieve analysis of the particle size distribution, characteristics of fraction passing number 40, such as the liquid limit and plasticity index information, is also included and presented in this table. This table also gives us the usual types of significant constituent materials. For example, if we are having A1 material means that these are having stone fragments, gravel and sand. A3 material is fine sand. A2 material is silty or clay, gravel and sand. Now, after knowing the usual types of significant constituents, you need to provide the AASHTO is providing us the general subgrade rating, and that is excellent to good. So we are having 3 groups and 6 subgroups here, and that was these groups and subgroups for the granular materials. Similarly, if we are having fine grained soils or silt clay materials, which means that more than 35% of total sample passing number 200, so you can classify in A4, A5, A6 and A7, and A7 is then further divided into 2 subgroups, A75 and A76. Again, sieve analysis, percent passing information for number 10, number 40, number 200 sieves are also given. Characteristics of the fraction passing number 40 sieve, such as liquid limit and plasticity index, are also given. The usual types of significant constituent materials. These types of materials are silty soils. However, A6 and A7, they are grouped as the clay soils. General subgrade rating will be fair to poor from left to the right sides. We are having 4 groups and 2 subgroups. Now, when we reach to the A7 material, we need to further divide into subgroups of A75 or A76. If the plasticity index is less than or equal to liquid limit minus 30, that would be A75 material. If we are having plasticity index greater than liquid limit minus 30, that would be A76 material. Now, how to use this table? The soil is classified according to the table by proceeding from left to right, top to bottom, column by column on the table to find the first group in which the soil test data will fit. Now, the first group from the left into which the test data will fit is the correct classification. The classification process stops at this point, regardless if another column farther to the right can also qualify. There is another parameter which is known as group index or GI. This was to establish the relative ranking of a soil within a subgroup or a group. This helps in evaluating the quality of a soil as a highway subgrade material. Now, the group index is dependent upon the percentage of the soil passing the number 200 sieve, liquid limit, plasticity index, and this is the equation. Group index is equal to percent passing number 200 sieve minus 35, 0.2 plus 0.05 liquid limit minus 40 plus 0.01 percentage of the soil passing number 200 sieve and the plasticity index. The first term is dependent upon the percent passing, soil passing the number 200 sieve and liquid limit, and the second term is dependent upon the percent passing number 200 sieve and the plasticity index. Now there are rules for determining the group index. For example, if group index is negative value, take it as 0. Group index is rounded off to the nearest whole number. There is no upper limit for the group index. The group index belonging to groups A1A, A1B, A24, A25, A3 will always be equal to 0. When calculating the group index for soils belonging to groups A26 and A27, so you can use this partial group index for PI, should be used. Now the group index value is written in parentheses next to the AASHTO symbol. For example, if we classify the soil as A26, then we will find out the group index, like in parentheses you can write 3, or A4 in parentheses you can write 5 as well. Now what is the practical significance of the group index? In general, the higher the group index, the less desirable is the soil for use as a subgrade. A GI of 0 indicates a good subgrade, and GI or the group index greater than or equal to 20 indicates very poor subgrade material. Now let's solve an example on it, then we will understand more that how the AASHTO soil classification system works and how we can use that table. Sieve analysis and plasticity data for two soils are given in the table. Classify soils according to AASHTO soil classification system. Sieve sizes are given: number 4, number 10, number 40, number 100, 200, liquid limit and plastic limit information is also given in that table. Soil 1, which is just an arbitrary name, soil 1% finer, soil 2% finer, so 100, 100, 99, 90, 75, 110, 50, and similarly for soil 2 is also given. Now we need to classify the soil 1 based upon the data which we got from the sieve analysis, and we are also given with the table for the granular and the silt clay material. Now we need to determine from left to right. Seeing that, first of all we need to answer the yes or no question or maybe questions, and then we need to move from left to right. For example, if I start from the number 200 sieve, how much is the percent finer? It's 75. Is it less than or greater than 35%? It is more than 35% passing. So definitely we can omit this portion of the granular material. So we can start from here and then we can move. How about the now we can clearly see that it's 35%, 36 is minimum. However, we are getting 30, 75, it's okay. How about the liquid limit? So for the liquid limit, now we need to compare that liquid limit is 110, but however here for the AS4 material it's 40. So we need to, is the answer is yes or no? The answer is no, so we can cross that. How about 41 minimum? For 41 minimum, this is the liquid limit information, so it's okay, yeah, it's maybe. Now how about the plastic limit? So plastic limit is the maximum here, so we can cross that one as well based upon the information of the plasticity index. How about the percent finer? 200, okay, that's 75 minimum, that's good. 40 is the maximum, no, that's wrong, so that's why we can cross that one as well. Now for the information which we have of the percent finer, for example 36 is minimum, yes, It can be more and more. So 75, the number 200 passing percent passing is minimum here, 36. So that is yes. Now how about the liquid limit? Liquid limit is 110. Here we are having minimum 41, so that is also yes. And how about the plastic limit? Okay, we need to find out the plasticity index here, that is 60. So we were using 50 initially, that is the plastic limit, but here we are having plasticity index. So plasticity index is 60. So 10 is the maximum here, that's why we crossed this column. We also crossed this 10 maximum, and we crossed this one, the 11 minimum, but 40 maximum was crossed due to the liquid limit value, because it's 40 maximum. However, we are having 110 here. So these two are okay. Now 11 minimum for the plasticity index 60. So plasticity index is 60. So be careful when you are reading the table. You need to focus on the plastic limit or plasticity index. So you need to focus on the plasticity index, as you can see here, plasticity index and the liquid limit. And how you can find out the plasticity index? It's the liquid limit minus plastic limit, and both these information are given in the table. Okay, so the soil is A75 because plasticity index is less than liquid limit minus 30, or 60 is less than 80, so we can classify that soil as A75. Now there is another problem number 2, and in the problem number 2 we can clearly see that percent passing is 2% from number 200 sieves, so that would be 35% or less passing 0.075 millimeter. So we can cross this one and we can focus on this one. Liquid limit information is not given. You can take it at 0, you can take it at 0 as well. So we can start from the left side. So all answers are yes, because maximum here we are having from number 10. How much is that? 20. So maximum, so it's within that range, yes. And for the number 40, how much is the percent passing? 10. Okay, maximum is 30 here, so that's also yes. For number 200, 15 max, yes. So the soil is A1A. Pretty much simple. There is another problem that 95% of a soil mass passes through the number 200 sieve and has a liquid limit of 60. Liquid limit of 60 and plasticity index of 40. Be careful about the plastic limit and plasticity index. So plasticity index is used in the table. Now we need to classify the soil. So we can start from the left side, and as we can say 95% of soil passing through the number 200 sieve, so we can straight away cancel this granular material and we can focus on the silt clay material, and we can answer yes and no for different columns, and we can find out that this will be the A75 or A76 material. Now you can see that 36 is minimum for the number 200 sieve, that's okay. Then 41 is minimum for the liquid limit, here is the 60, so that's also yes answer. Plasticity index is 40, 11 is minimum here, so that's also okay. Now we can find out plasticity index, whether plasticity index is greater than liquid limit minus 30 or less than or equal to the liquid limit minus 30. So we can find out that the plasticity index, which is 40, is greater than 30, which is liquid limit, that is the liquid limit minus 30. So if plasticity index is greater than the liquid limit minus 30, that would be A76 material. We can also find the type of soil using plasticity chart, but this chart is not used for A1 and A3 type material, mainly non-plastic soils. Now, for example, this chart is plotted on the x-axis is the liquid limit and on the y-axis the plasticity index. Now, if the location comes along the border line, we need to consult the table, and the grain size will tell the classification of the given soil. For example, if we are using this plasticity chart to find the type of soil from problem number 3, so we already know that the liquid limit is 110 and the plasticity index is 60, so it would be A75 material. Why? Because percent passing through the number 200 C is greater than 35%, so we can classify that soil based upon the liquid limit and plastic limit here as well. Thank you very much for watching this video and the AASHTO soil classification system that is being used mainly by the highway engineers, transportation engineers, and that was all about the AASHTO soil classification system. So I hope you are enjoying my videos. Please kindly like, share and subscribe to my YouTube channel. Assalamu alaikum and Allah Hafiz.